Thank you. Thanks, Lisa. Appreciate that. So I'll be talking today about what we discovered in our journey to estimate statewide pedestrian and bicycle miles traveled for the state of Washington. And I was working with a graduate student at the time, Mike Selinger, who was in the Masters of Urban Planning at the time and is now working for ALTA. And he may be able to speak at the very end if people have questions, if he's available. And I want to thank the National Institute of Transportation and Communities for their funding for this part of the work, and also Washington DOT, who funded earlier stages of the work and is continuing to fund this important research. And I want to thank my partners at Portland State and also my partners at University of North Carolina Highway Safety Research Center, where I'm currently working, and the folks at the Pedestrian and Bicycle Information Center. And we also have Taylor Phillips, who helped out at the part of this project when she was a student. So I'll start with the purpose of why we want to understand cycling and walking on the state level, and then get into what we can learn from motor vehicle counting and estimation of vehicle miles traveled. Then we'll get into what we actually did in this study, and then the results, and then some generalized conclusions for what we can learn going forward and recommendations for what we should do in the future. So the purpose of walking and biking, all of you on this webinar, I'm sure, already have good reasons for measuring cycling and walking, but I want to go through and talk about the different levels at which we need to understand these metrics. So for funding and policy decisions, we really want to understand what's going on both at the facility level and the city level and the state level, because we want to understand, do we have change over time? Do we see increasing or decreasing cycling and walking? What does that mean? And then on the facility design level, we really need to know on this bike lane, on this bike path, on this sidewalk, how many people are using it, when are they using it, in order to do good and appropriate design. And then for economic impact, we need multiple levels. Health impact, maybe more on the larger level, but also we need to know. And then safety, we really need all levels. So for different questions and different purposes, we need to know different levels of where people are cycling and walking. And this research focused on the state level, but did not forget that we also need to know what's going on the facility level for these other purposes. So we'll just keep that in mind as we go through. So on the state level, I'm going to be using these two acronyms, bicycle miles traveled and pedestrian miles traveled. So let's go back. Some of you are very, very, very familiar with motor vehicle traffic monitoring, but I want to do a quick review so that everyone on the webinar is on the same page and what we can learn from this for biking and walking. So on the state traffic monitoring, this is how we get the vehicle miles traveled numbers that are aggregated and used to start allocating money from the federal government highway trust fund to the states. This has traditionally been used as, okay, states with more vehicle miles traveled may be receiving more funding from the federal. So permanent counters are used because we want to know how many people are using the road, how many vehicles are driving on the road, and that would be great if we could put permanent counters everywhere and know every road segment how many people are using that road, or how many, in this case, cars or trucks are using that road. Unfortunately, it's very expensive to put these in, so the state DOTs use short duration counters, which are usually pneumatic tubes, rubber hoses, to count on all these segments where they can't afford to put the permanent counters. And they rotate those. They don't necessarily do each one each year. Okay, so our permanent counters in the state of Washington, you can see that a lot of locations we do not have permanent counters for motor vehicles. But at all the locations where we do, we can very easily compute the annual average daily traffic by taking the total counts for that year and dividing by 365 to get an estimate of the annual average daily traffic. And from that, if we knew it everywhere, we could then estimate the vehicle miles traveled and we'd be done. But of course, we can't know that at the short duration count locations because we only have 48 hours or 24 hours at those motor vehicle count locations. So what do? We create an estimation procedure based on the season, the time of the day of the week. We create these factors at the permanent count site, we apply them to the short duration count site, and we then extrapolate up to annual average daily traffic at all those short duration count sites. And then, since we now have estimates across the entire network on every segment, or basically every segment, we can know the vehicle miles traveled by simply multiplying by the length of the segment and summing over the entire network. So that's the basic concept. Can we apply this method for biking and walking? I'm going to start with some acronyms here. Annual average daily bicycle traffic, and I believe this is the official FHWA, Federal Highway Administration acronym. Annual average daily pedestrian traffic, AADP. Okay, and if that weren't enough, we now have annual average daily non-motorized traffic. Okay, so I'm not going to use that last one, but we'll stick to the AADBT and the AADPT. Doesn't really roll off the tongue, but I'm working on it. Okay, so data that we have available. So in 2012, when we started this study, Mike and I looked, and all we could find was one permanent count site for biking, actually for bicycling only, not walking, for bicycling only, in the entire state of Washington. So one of our first things we did is we told the state, we wrote a memo saying they could probably put in some more. And unbelievably, they listened to us and they put in more counters. So it was very exciting. And now I just checked, these are the sites all over the state that now have permanent bicycle and pedestrian counters, and all those red dots indicate places where they're counting bicycles and pedestrians separately. So this is great news for future research. When we did this study, however, we were stuck with the 2012 data at one site. And then short duration count sites. The state runs a volunteer-based count program and in 300 locations, cities around the state, 300 locations, sorry, around the state, and these are just a sprinkling around the state. So you can see they've got pretty good spatial diversity for a short duration statewide program. But these are counting 2 hours and 4 hours. Sometimes they count morning and evening at the same site, and usually on a day in September or October. So our one site is in Seattle. It's on a bridge. It has a nice little display right there, and that is on the Fremont Bridge. And we have a nice commute pattern here with people going in the morning on the weekdays and then coming back in the evening around 5 p.m. Very clear commute pattern, and then not as many people on the weekends. Clear commute pattern. Now, is this appropriate to look at for the entire state? Let's think about that. We have 2,461 annual average daily bicycle traffic on this bridge, which is great. That's relatively high. Nice numbers to work with. And again, more during the week than during the weekends, and higher in the summer than the winter. Very seasonal here, higher in the summer than the winter. Should we apply this across the state? Let's keep thinking about that. I don't think so. And why not? Let's go back here. Because the state is very different. We have lots of different weather patterns across the state. We have lots of different events going on around the state. Not everybody is commuting to work. There are recreational patterns. There are patterns for people going to school. So this pattern that we're seeing in Seattle may not apply, and probably doesn't apply across the state. Okay, so factoring method that we're using to extrapolate our short duration counts. Remember, we've got 2-hour counts, and we want to get to annual average daily bicycle traffic and pedestrian traffic. So What we'd like to do is know the variation by month, and that would require us to know what's going on a continuous count station in the region that we're studying. Then daily and hourly factors. So we're going to take that 1 hour period that when the count is taken, divide it by the monthly average daily traffic. This is just a standard equation from the traffic monitoring guide. So here's an example for the month of December. We have only 1,000 on average per day at the site on the Fremont Bridge, but on average we have more like 2,000, so that's a factor of 2, meaning that December is half the counts of the rest of the year. So we came up with factors, and you can see here's December at 2. April is about average, so that's 1. And when we usually do the counts in September and October, when they do the manual counts, that's also around 1. So that's nice that they're choosing a representative month, but still good to adjust for weather activity. Now this is the daily conversion from from hourly to month. So here we took the for 7 a.m. to 8 a.m. for example, for the month of June on a weekday, divided by the monthly average daily traffic there. Okay, so again, should these now be, these are only based, remember, on our one site in Seattle. Should those be applied across the state? No. But that's the data we have. So non-motorized data, other data that were available, maybe there's some other data sources we could use. So we looked at those and we found there were travel survey data. But the problem was not that we did have a representative sample, but we can't get facility level information on that. So if we want to understand what's going on this bike lane, that is not going to get us the answer. The GPS data, so this would be maybe from an app on your phone, or there are many other ways to collect this, but usually it's from an app on the phone. So that's great, but again, there's a self-selection bias here, so we can't use that to necessarily represent all users on the road or path or sidewalk, and it's more used by cyclists than pedestrians. Okay, and then continuous and short-term counts, we've talked about those. We need additional data there. And then spatial variables, we do know what type of road it is or path. We know the land use around it, is it urban or rural? And we know the basic geography. So that's good. We have a good idea of that. And then the socio-demographics and the population. So if we combine some of these, can we get a better estimate? So here are the methods we decided to explore. We decided to explore 3 methods, try to triangulate on the problem. So we explored the sample-based approach, which is taking that VMT method I discussed at the beginning for motor vehicles and applying that directly to bicycling and walking. The aggregate demand model is a common approach for how we deal with these types of problems in cities, especially for pedestrians. So we're going to take all those socio-demographic and geographic variables and create a statistical model and then estimate it that way. And then the travel survey approach. This was really kind of a back-of-the-envelope approach because we do not have detailed travel survey data across the state of Washington. So this was just to compare national data to what's going on, to see if we're in the right ballpark. So both of the first 2 methods I talked about rely on the annual average daily bicycle traffic, the ADBT and the AADPT numbers, the count data. They both rely on the count data in order to come up with estimates. In the first case, we're just multiplying by the segment length, and then the second case, we're using that socio-demographic data to come up with the estimates. The sample-based method, it assumes that we have a stratified random sample. Now, were our short duration counts collected at randomly selected locations? Unfortunately not. They were selected for specific reasons, which is also valid, but not applicable for this method. So it was local volunteers and coordinators who were selecting these count sites for volunteers to go out and count, and they were not selected randomly. So that's going to be an issue. And if we do a stratified random sample, as I'm suggesting here, what are the strata that we want to use? So we thought about that, and we looked at the research on what impact bicycling and walking, and we came up with 3 main strata that work for both bicycle and pedestrian volumes. So the first was urban versus rural, level of urbanism. So that's 2 strata. We considered looking at suburban, but found it very difficult to come up with a standard definition for that. So we left it at urban versus rural. We looked at different facility types, so arterial and highway and roadways, and then local roads and collectors, and then we realized first we lumped the trails in with the local roads and collectors, but when we actually looked at the data, we found a big difference between the volumes on the trails, which were very high where they were being counted, and the volumes on the local roads. So we separated those out, ended up with 3 categories there, 3 strata. And then geographic and climate regions, we took the EPA's ecoregions, which describe actually plant life, but they also have a good correlation with weather and climate. And we divided the state into 4 regions: the Coast Range, the Puget Lowlands, the Cascades, and Eastern Washington. So there's 4. So you multiply that out, and now we're at 24 strata, 2 times 3 times 4. Here's what it looks like on the gray is the urban area. The different colors, we have the 4 regions of the state based on the geography and the weather. And then the little dots are our count sites. And you can see that we have a lot of urban areas in the 2 Puget Lowland and the Eastern Washington region, and very, very few counts in the other 2 regions, which makes sense because that's where most people live. Okay, so we have our 24 groups. We could take the centerline miles for each, compute the AADBT and the AADBPT for each, and then we can get the PMT and the BMT, okay? So this assumes that we have estimates for each segment, and it assumes then that we're taking the average, that we have this representative sample that can be used to estimate what's going on all those segments. So that's a bit of a leap of faith, and if we had a random sample of each strata, maybe we could agree with that, but with the sample we have, that may not be an appropriate method. Okay, the aggregate demand model, here we're also taking the counts, but we're using other variables. So we kept the facility type, the local collector roads and trails and such. We added a bridge variable because Mike Selinger found in the data very quickly that bridges were very high volumes in our data. And so that was just a dummy variable, is it a bridge or not? Population density, we were able to add that. The age, age 18 to 54 or not. Education, does the population, percent of population with 4-year degree or more, and put that into a simple least squares regression. We could have made a more complicated, maybe a negative binomial estimate and negative binomial model, but for the first cut at this, we just used the ordinary least squares regression. And then the back of the envelope method, our National Household Travel Survey, we used some research from Puker et al. And estimated just based on national numbers. multiply it by population. Simple method. We did look at also the Puget Sound travel survey, but because that did not go across the entire state, we stuck with the national numbers. Okay, so results. Our sample-based method, again, I've told you all the reasons to be dubious of these numbers, and we could only estimate for 2 regions of the state, but they were the most populous. So we found trails were highest, biased towards overestimation because we are not sampling randomly. And one of my goals here was to try to get some sense of what was going on, what order of magnitude we should be expecting. So 5,000, 1,500 million miles in those 2 regions, probably on the high side. Okay, so aggregate demand model, we were not able to estimate on the whole state because of some computational problems. Our computers just couldn't handle that much data. So we stuck to one county, one of the most populous counties, King County, and we used all the data and then estimated volumes on all of the segments and multiplied by 365 to get to the estimate of the total for the city, the total pedestrian and bicycle miles traveled for the county, sorry. Okay, and I'll show those results in a sec. Now, the simple back of the envelope to compare to see are we in the right ballpark. We were able to use this method across the entire state, and you can see it's much lower than the numbers I presented for the 2 regions, 700 pedestrian miles traveled, 200 bicycle miles traveled. So big discrepancy, about an order of magnitude difference here between the numbers we're getting from these 2 methods. So to do a good comparison, we were working with Chris Monsieur at Portland State University, professor in civil engineering, and he said, well, you need to compare, so let's choose the county, one county where you can use all 3 methods and see what numbers you get. And you can see these numbers vary quite a bit with the PMT varying from 200 to 2,000. So, and the bicycle miles traveled from like 45 up to 1,000. So again, an order of magnitude difference between these methods. And then just for fun, I decided it would be great to compare this against the vehicle miles traveled. So if we look at our estimates from the sample-based and the national survey-based, we see that we are like 10% to maybe less than 1% of the vehicle miles traveled. So I think we are at least we have defined where the ballpark is, but we need to get a little bit better data before we're going to be able to really pin this down. So we also wanted to compare what we were finding to other studies, and the green here indicates other studies. The blue bars are our research. This is just the bicycle miles traveled, but you can see at the top here, these are the survey methods, and then at the bottom of the graph, the larger bars are the count-based methods, or the sample-based methods, I should say. So the sample-based methods were getting a lot higher volumes than we were predicting with the survey back of the envelope approach, except for this one study that was done in the Twin Cities, that one there in the middle of the graph. And this was conducted back 15 years ago in the Twin Cities in Minneapolis, St. Paul. And they actually got a random sample because they were running the entire study for this specific purpose and not using secondary data as we were. So they had a random sample, and you can see that it's more in line of the bicycle miles traveled per person per day that we would see from and expect from the national survey. So that's both good news and bad. It's good news that we have some relationship there, but it means that perhaps our count data with the bias towards counting at locations where there are actually people walking and bicycling may be overestimating by quite a bit. So this underlines the need to estimate to have better data that's more representative if we're going to use this method. And the very bottom line there, the King County, Washington, that's our aggregate demand model. So you can see it's based on the count data again, so it may be biased toward overcounting, but it is significantly lower, indicating that it is taking into account some of those biases because it has the demographics included. So perhaps a little more accurate there. Okay, so what does this mean? How can we use this information? How can we generalize what we've learned from our adventure in the world of estimating pedestrian and bicycle miles traveled, or trying to estimate it for the state of Washington? So the sample-based method that we looked at is great if you're looking at the facility level, and you counted on that facility, but when we look at the state level, we have these biases that we need to make sure we're accounting for by doing the random sampling, and it's also harder for the pedestrian numbers because pedestrians are less likely to always travel on the specific location you're counting. They like to cut across parking lots, go through alleys, go into buildings, so they're more diverse and a little bit harder to quantify with counting. The aggregate demand model has some pros because it accounts for more things. We're able to take into account the demographics, which is especially useful at the pedestrian level because people are more likely to not stray, to walk closer to their house or their work. For bicycles, though, people tend to bicycle farther from where they live or work, so those demographic variables are not as powerful. And it's hard to get all this data and to implement this at the state level just because of the sheer computational problems, and also it's just a little more complicated. You need a statistical package to use this method, but it did seem to get some more accurate numbers. So we think for bikes, a sample-based method may be more appropriate than for pedestrians. Where pedestrians, it's more important to be getting that aggregate demand model. And all of these can give us data on the facility level, and we can go to the state level from the facility level by summing all those facilities to get to the state level. But this travel survey is really a method that is most useful for the city or state level, and we cannot get down to the facility level with that data. So that's the big problem with that approach. Okay, well, with all these problems, now let's not get too depressed. There is hope and there is progress. So we are improving the count program. The Washington State Department of Transportation is actively improving their count program, and as I said, expanding their permanent counters. And we also want to work with them in the future to remove bias if we're going to use this approach. And then travel surveys, if we could get a larger sample using the National Travel Survey or doing a state-specific survey, that would be useful. And then there are other data sources that we explored in this study that I did not mention, but one of the most promising there are the GPS apps. If we can integrate those with the count data, we could get a better way of filling in the gaps between where we have actual counts, because we cannot afford to count everywhere. So lots of future research and future areas where we can expand and do a better job of counting and measuring bicycling and walking. Specifically, for those who would like to improve their permanent count program, which I think is a great idea, we want to expand and include diverse geographic areas, rural and mountain regions, as well as urban regions. We want to count on both paths and roads, and sometimes that's difficult. It's sometimes easier to count on paths, but we also want to count on roads. We want to choose sites selectively, not randomly, but selectively for the permanent count sites. We want to choose sites, and that's important because we need to choose sites that work for these automated equipment and sites with moderate to high volumes. Now the problem is we do need to still sample in rural areas where volumes are low, and so for the time being we will have to put these counters in low volume areas, but if possible, if there are any higher or moderate volume areas, those are easier to work with the data, because if you only have 5 people going by per day, it's pretty hard to do statistics with that. But for rural areas and mountain regions, we will have low count locations, and that's okay. We need to separate bicycle and pedestrian counts because pedestrians and bicyclists have different travel patterns. And the state of Washington is doing that. It's good to see. And we need to install at least 1 permanent counter per strata. I talked about these strata, but per region and facility type. And ideally, I'd like to see 7 per factor group. So factor group means the behavior. So if you have a commute pattern, for example, that is a factor group. A commute pattern in this region, that's 1 factor group. The recreational pattern in that region is another factor group. So that would mean a lot of counting. But I think bicycling and walking, the patterns we're seeing are more variable than what we see for motor vehicles, so it is appropriate to install perhaps even more permanent counters for these modes than we have historically had for driving. Okay, I asked my current grad student who is working with the current data, to give some input on, his name is Dylan Johnstone, to give some input on what we can do better for this data. And he mentioned we want to document any equipment malfunctions and special events that happen, because someone looking at the data later may not know that you had a really great event on your path and may think that large spike is a problem. So if you can document that, that would be helpful. And taking photos of the site is very helpful, even the short duration count sites, so that future researchers can know better what type of facility it was on, where exactly the counting was done. And then validate your equipment. Even if you validate it, you find a problem, you fix the problem, recalibrate it again, validate it again, and because we need to know, well, it's better, but it's probably still not 100%. So what is that error associated with that? Is it an undercount, or what's going on, so that you can account for that better? And there's great information on NCHRP 797 report that's available for free online. I have all these references at the end of the presentation. Okay, short duration counters, what can we do better? So for the purpose I'm talking about, it is useful to have a random stratified sampling approach. So we've talked about how those strata could be chosen and then sampling randomly around your network. And we don't have to count at every location every year. We can rotate those locations just like we do for motor vehicles. If we have the good set of permanent counters, the permanent counters are telling us how travel varies with time. The short duration counters are telling us how does travel vary over space. They have a different purpose. So we don't have to rely on those to tell us, they should not be telling us what's going on over time. They should be telling us what's going on over space. So we can rotate those and not have to sample the same site every year. And that'll allow us to find out what's going on around our network better, instead of being stuck counting the same site every year. And I'd ideally like to expand these short duration count programs to cover at least 150 short duration count sites per group. And ideally, we'd want to count 7 days per site using some automated equipment like a tube counter and a infrared counter, as we see at the bottom of the page. Here's the tube counter and the infrared counter. And using those together, If you count with the infrared counter, it counts all the warm bodies, and the tube counter can count the bicycles, and then you could subtract the warm bodies from the tubes to theoretically get an estimate of pedestrians, which again is very nice. But you don't have to do that. And sometimes, for example, this is a pedestrian-only trail. You've separated the pedestrians out in a different way. So that can also work. You don't have to count the same mode, for both modes at the same site. So ideally we do 7 days per site. That's what researchers, including myself, have found. But I'm still not willing to give up on the shorter manual counts. Manual counts have their place. You can understand the helmet wearing, you can get gender, other variables that you cannot get with an automated equipment at this time. So I think these all have their place, and we're working on a study right now to understand what the error associated with doing these estimates that I've talked about in this presentation. What is the error with doing those short-term manual counts and estimating your annual average daily bicycle and pedestrian traffic? I think in the best conditions, when we count in September on peak hours and we know what the pattern is, I think we can really minimize that error, and it may not be as bad as we think. So I'm not giving up on these manual counts, but in a perfect world, yeah, sure, I'd love to have 7 days, because then I know, do we have highs on weekends or do we have highs on weekdays? And I know what's going on throughout the day. Do we have a peak at commute hours or during the middle of the day? So ideally, we should count longer, but let's not give up on manual counts. Okay, and we can combine these. We can do both. Okay, and counting separately, pikes and peds. Travel survey, a simple approach could be to just expand the oversampling for the National Household Travel Survey, or you could establish a statewide household travel survey. If all you care about is the state level, this is probably an easy way to get there. But again, it's not going to get you to the facility level and those answers that you need for other purposes. GPS data, this is just an example of the Strava website. There are other apps out there, Ride Report, Ride with GPS, many other apps out there collecting this data. Some of them are specific to states, but do not think, okay, Krista showed this graph, this map, you can go online, it's free, just, oh, now your problems are solved. And you do have to pay for the data if you want the detailed data. But this data is nice and helpful, but it should not be used in isolation. It needs to be combined with the count data, because the count data give you your ground truth. And when you relate that to something, another data source like this, then you can start doing estimates, filling in the gaps where your count data are not giving you information. But to use this in isolation without the other data and without understanding the bias of the users of these particular apps, because these are not randomly selected users in general, unless you've done a specific study, we need to understand that bias, and we need to account for it properly. So count data are the basis for all of these other estimates and combining these other data. Okay. Next steps, we are continuing to work on this. Thankfully, the Washington DOT has continued to fund research on this. I'm working with Dr. Mike Lowry at the University of Idaho on our next steps. We are going to write a guidebook for communities and take what we're learning about when to count. We're currently making more factors with all this extra data that the Washington Department of Transportation has provided. We're studying when is the best time to count, and Mike Lowry is studying where is the best place to count, and then we're going to create a guidebook based on that research. So look for that in the coming year. I just wanted to provide some of the free references that are available on the web, so that if you want to know more about counting, about some of the things I've talked about, here are some great resources. And so I'm just going to wrap up and thank again NITC for their help. Washington DOT, folks at University of North Carolina Highway Safety Research Center, who are I'm continuing to work with here, and also Portland State, who has helped us out with this research. And I think Mike Sellinger may be on the line, and we can add him in for this question and answer session because he may be able to add some knowledge since he worked on this very much. Okay, thank you so much for your attention.
Great, thank you, Krista. It was a great presentation, and that's very exciting to hear about that guidebook. I think a lot of people will be interested in that when that comes out. All right, we'll go ahead, and we've got a few questions here, so continue to submit your questions if you have them, but I'll go ahead and get started with a few questions that we already have. So one question is a general question, and you've sounds like most of the data is pretty generalized and could be easily transferred to other states. Is there any pitfalls to watch out for, or highlights as people may want to transfer this kind of information or data collection to their state or jurisdiction?
Sure. So I think the methods are very transferable. I talked about this sampling method, and that's something that you could do anywhere. You can do it on the smaller scale, on the city level. You could do it on the county level. You could do it on the state level. And again, if you're working on the state level, using some of these secondary data sets to fill in some of the gaps may be useful, especially when it's so hard to get all the count data right away. But one thing I do want to caution is I put some numbers in here that were specific to that one location in Washington State on that Fremont Bridge. Those were the factors we came up with to illustrate how to do that, not to be used by others, because obviously that particular set of numbers is really only appropriate for that year, 2012, and for the area around the Fremont Bridge in Seattle.
Okay, great. And it looks like we have a few questions regarding the GPS data that you had mentioned. So one question is, how much does it cost, and is it difficult to process? And then similarly, have you compared any of the GPS data counts to permanent counters, and did you see a difference? And then finally, have you tried to create a Strava using some of the tube count factor based on the Strava Metro data that they've purchased?
Oh wow, lot to that question. Okay, that's a very good question, and the answer is no, I have not personally done this. However, there are researchers out there who are doing it and continue to work on that particular approach. Luis Miranda Moreno, for example, at McGill, his team is working on that. Other researchers have also worked on it. Okay, let's start with the beginning. So how much does it cost? I do not know. I do know that Oregon Department of Transportation and other departments of transportation have purchased it, so you'd have to ask Strava Metro. And how hard is it to process? I have heard that from the vendor, they have told me that, oh yes, we will make it very easy for you and provide it in the, in a GIS that would be useful to you. So that's what the vendor says. So I think we'll have to ask someone who has used that. Perhaps, I don't know if someone's on the call who's already worked with that data. Maybe they can write into the chat pad about what they've learned. And other types of data of this sort. So many of you may be familiar with other apps that were open source. Originally in San Francisco, they came up with an app to do some tracking, and that app has been used by many researchers around the country and into Canada to create their own specific apps for their jurisdiction. For example, Oregon has OR Cycle, and I think Puget Sound has their own app. So, and Cycle Atlanta, and anyway, it goes on and on. There are many, many agencies using some version of this app, and research has been done in Georgia and Oregon and many places to look at that type of data. But for all of these, whether you're using the private data or a public data source, you still have the bias that you have to account for. And you have to know who are using these and how that bias may be influencing how you're filling in the gaps between your count data. So the count data are really key to understanding, am I getting a good sample of the urban riders, or am I only getting recreational users? Or am I only getting urban riders, and you know, some of these are really for people who are cycling advocates. They're marketed towards cycling advocates, or they're marketed towards college students. So that's going to bias your sample, and understanding how your GPS data is biased in that way is really important when you're using these types of data. But it is a promising data source. If you are interested in understanding what's going on in your city or in your campus area, then it's a pretty good way to saturate users, and if you have a group of people who are using iPhones a lot, then you might be able to get pretty good numbers. So on the state level, though, I think it's great for sampling. Like the Strava data really appeals to people who like to do recreational riding, and so that could be very useful when you're looking at state level rural roads where we have a real challenge with count data. So there's definitely a place for it, and I'm glad to see a lot of research going on in that area.
Okay, and we have a couple responses from the audience, so I'll just go ahead and read those quickly with their experiences. So the way I got it was a GIS layer for the street network and a table of user link counts for each minute of the year, which for the city of San Francisco was a 3 gigabyte table for 1 year, so bigger than you can handle in Excel by quite a bit. And then another response was, the company does roll up the data into times of day, AM rush, midday, PM rush, etc., and they split the data out by month and weekday, weekend. It is still a little cumbersome to work with and requires a fair amount of GIS processing. If you want to get down to the minute or hour, it requires more advanced SQL skills. So thank you for your feedback. All right, and so let's move on to another question here. So let's see here. Do you tie evaluation of bike ped needs based on land use and zoning? Isn't this what ADT methods for traffic? Also, is there any data to determine bike storage, bike racks, lockers, etc., based on land use?
Okay, so that last question, I have looked at the counts from bike parking and thought about using that, but I never have because it's more of an origin destination question. It's a different type of data. So you don't know where those folks went, you just know where they ended up. So it's a little challenging to use when you're trying to figure out how many people are on this bike path, or how many people are on this bike lane, or how many people are on that sidewalk. And especially for pedestrians, obviously that wouldn't give you much information. Can you read the first part of the question again?
Yeah. Do you tie evaluation of bike ped needs based on land use and zoning?
Yeah, so that's why we were looking in this study at the land use, and we did explore the option of getting more into land use. But again, we were focusing on the state level, and because of our focus on the state level, we just took that and very generalized. So we did not look at getting down to commercial versus residential neighborhoods. And I think when you're talking about pedestrian travel and you're looking at the city level, then that becomes more interesting and more useful. But on the state level, we needed something that was a little simpler, so urban versus rural and maybe suburban, if we had a good definition for that.
Okay, great. And then we have a specific question on one of your slides on the better data needed. You had mentioned 150 short duration count sites per group. And on this slide, what does group mean? in that context?
Good question. Good question. So I was talking about the strata that I mentioned earlier, where we have the urban-rural, the geographic, and we had the 24 strata, 4 geographic regions for the state, and then the 3 types of facilities. So that's what that meant. Thanks for the clarifying question.
Great. Okay. Another question here. How do you see the PSU Bike Ped traffic data portal making statewide activity estimations more doable?
Well, it's a source for this data, and you know, people who know me know that one of the reasons I enjoyed so much being at PSU is I got to work on the Bike Ped data archive, Bike Ped Portal, where we're taking count data from around the country and putting it in one place. And I think this is a very powerful concept, because when we can aggregate data, we can really make the best use of it. So for example, for Washington State, when we looked in the follow-up research project, we've been looking around the state for additional count data in addition to the short duration count sites and the permanent counters that Washington Department of Transportation has. We found that in 2010, there was a parks department north of Seattle that was gathering all sorts of permanent count data on their trails, and we are able to use that for research. And then the city of Olympia has been gathering short duration count sites using tube counts to count bicycles on their road network and path network. And we found counters in Spokane and Redmond. So there was a wealth of data, and I think this is true for most states. Whenever I've looked into other data sources for count data other than just the state DOT, I'm always amazed at how many parks departments and cities and counties are collecting this type of data, but you won't get it until you ask. And Bike Ped Portal provides a place for us to start putting that. And it's also working on the National Bicycle and Pedestrian Documentation Project, which I haven't really talked about, but has been kind of the basis for a lot of this work. So Bike Ped Portal is working with the National Bicycle and Pedestrian Documentation Project and ALTA to take that data and start putting it in one centralized database so that researchers and others can start using it with all of these other data sources that are now available. So combining the permanent count sites and the short duration count sites. So one of the outcomes of the research we're currently working on will be to create this estimation procedure built into Bike Ped Portal so that you can estimate annual average daily traffic from at your short duration count sites using factors like the ones I've talked about. So a lot of great work going on and a lot of excitement in this area, and when we have a platform that we can help us do these analyses, it will definitely make them easier for everyone.
Great. That's very exciting. Kind of segueing into that, accounting for bias, is there any tips or thoughts on how you can account for bias in either the GPS data or for the sample-based data that you had mentioned that may be higher than statewide counts?
So how to account for it? So I'll talk about the GPS data first. So with the GPS data, this is the value of the count data. You can use that, compare it to your numbers, as one of the previous questioners was asking, have I done this? And others fortunately are. I think someone, Josh Roll at ODOT is actually working on this as well. So taking those count numbers, comparing them to the number of GPS traces on that segment. What's that relationship? And once you can understand that and see, is it a consistent relationship? Is it something we can account for? That's research that's ongoing right now, and answering that question is going to be really important for using GPS tracking data in the future. So I'm glad to see other researchers working on that. I look forward to hearing what they find, and yeah, it's a great question. Now, the other question was the bias on the count data. And that's a little harder because, like I said, we need to do a random sampling approach to overcome that. So I encourage jurisdictions who want to do that to do random sampling.
Okay. All right, and I think we have time for one more question here. Is camera video data viable for counts or estimates?
Good question. Yes and no. Yes, if you can prove that it is working. And unfortunately, we've at Portland State, when I was there, we did some studies and we were not able to prove that. So I think it has great promise and it can work, but we need to keep working on it, because what I've seen is if you can get it calibrated for one site pretty well if you work at it, but then trying to just put that camera up and get that same accuracy is challenging. So definitely an area of further development.
This is Mike Hellinger. One thing to add on to that, we are currently at Alta testing out the MioVision video collection unit in a bunch of different contexts and collection sites, and so we'll be releasing the results of that on and validating those counts to see how accurate they are.
Great. Thanks, Mike.
Great. All right. Well, thank you everyone for your questions. There were a few questions left unanswered, so we will make sure to just respond to those, and we'll also send out the video and Krista's presentation slides. So this concludes our webinar. Thank you for joining us, and thanks again, Krista, for sharing your work. You can also view other professional development offerings on our website, nitc.trek.pdx.edu, and this concludes our webinar. Enjoy the rest of your day.